Alright, this video is on the law of sines, and we're also going to talk about law of cosines. What these do is it helps you find missing pieces of any triangle, not just right triangles. So you can find the missing angles, missing sides, using the law of sines and cosines. So the first one we're going to talk about is the law of sines. Alright, so the law of sines can be used to solve any triangle. And remember, to solve a triangle means to find all the missing parts, all the missing sides, and all the missing angles. To solve a triangle, when two angles and the length of any side are known. Alright, and we call that the angle side or the angle side angle case. Or when the length of two sides and an angle opposite them are known. Okay, and we call that the angle side case. I wrote a bad word. All right, so here's the law. Here's the actual law of sines. So sine of angle A over A is the sine proportion as the sine of angle B over B, or the sine of angle C over C. All those are the same. You can even flip it if you want. Okay, let's make a note. Make sure your calculator is in degree mode. We're going to work with degrees. So we're going to set up a bunch of proportions to find all the missing sides. Again, this works for any triangle, not just a right triangle. In degree mode. Okay, so now we're going to find all the missing parts of either an angle side case, angle side angle case, and we'll talk about angle side in a second. Okay, so we're going to set up some proportions and find our missing sides. So the law of sines, the sine of angle A over A is the same as sine of B over B, and the sine of C over C. Or you can even flip that. All right, so we're going to do examples, and we're only going to do them for angle side or angle side angle cases. Okay, we're going to do that first. All right, so first example, we're going to solve triangle A, B, C. And then just as a note, solving a triangle. And we're going to do two examples in this space, by the way. Means to find all the measures of the angles and the sides. All the angle measures and all the side lengths. Measures and all the side lengths. All right. So here's the triangle I'm actually talking about. It would help if I actually give you the triangle. That looks like a right triangle, so I'm going to make it not look like a right triangle. Pink, pink. Okay. So triangle A, B, and C. 107 degrees for this angle, 25 degrees for this angle, and 15 for the length of that side. Okay, so first thing we could find is real quickly the measure of angle A. And the measure of angle A, remember the angles of a triangle add up to 180, so we're going to do 180 minus 107 minus 25, and we get the measure of angle A is 48 degrees. Okay, now okay, So now we're going to find the missing sides, and this is in so hold on, we're going to find the missing sides. All right, so the reason why I can use the law of sines is because I'm given a side. Okay, so I'm given just one side but two angle lengths. So I'm given one side and two angle lengths. Then I can use the law of sines, or angle lengths, angle measures, I mean. All right, so first I'm going to find side A, and then we're going to call this side C, excuse me, side C. Side A is opposite angle A, side C is angle side C, and side B is opposite angle B. All right, so I'm going to find A first. So I know that side A, and then the sine of angle A, which is 48, is the same as 15, which is side B over the sine of B, which is 25. So the sine of this is angle A, and this is angle B. Okay, this is angle A and angle B. Side A goes above it, and the side opposite B goes above B. All right, so when I go to solve this, I'm going to cross multiply. So it's the sine of 25 times A equals 15 times the sine of 48. Going to divide by the sine of 25 on both sides. So I actually just type in 15 times the sine of 48 divided by the sine of 25 in the calculator. I get A is about 26.4. Actually, if we're going to put about, let's put the about symbols. All right, now I want to find side C. So side C is going to, I'm going to use the sine of angle C, which is 107. And I could use A or B, but I'm going to use B since they gave it to us. So B over sine B. So again, sine of 25 times C equals 15 times the sine of 107. Divide by the sine of 25. This is what I put in the calculator, and I get C is about 33.9. So now I know the missing lengths of those triangles, or of those sides and the triangles. All right, let's do another example. So here, I'm not going to give you the triangle. I'm just going to give you measurements from the triangle. Angle B is 102. And then side A, actually let's write this a little bit different. Sorry. The measure of angle A is 28 degrees. The measure of angle B is 102 degrees. And then side A is 8. All right, so again, they gave me two angles and a side, so I know I can use sine of the law of sines. Okay, I know I can use the law of sines to find the missing parts. So first I'm going to find the measure of angle C. And I do that by, again, 180 minus 28 minus 102, which gives me 50 degrees. All right, and I need side B and I need side A. So side B is going to be sine of angle B. Did I say I need side A and B? I need side B and C. All right, side A over sine of angle A, and I'm going to cross multiply. Sine of 28 times B equals 8 times 102, sine of 102. Okay, divide by the sine of 28. Put that in the calculator. All right, and I get B equals, well, it's about 16.7. And I put that in the calculator. All right, and you might want to put the calculator, make sure you can get the same number. I use the math frac button to do that. All right, so let's find side C. So C over sine of C, of angle C. And again, I'm going to use the A over the sine of angle A. Cross multiply, so sine of 28 times C equals 8 times sine of 50. Divide by the sine of 28. And I get C is about 13.1. All right, so that's for angle side, or side angle. So it's the side right after it, or it's the side in between. All right, so angle side meaning it's the side right after the two angles, or angle side angle, it's the side in between the two angles. So whenever we know two angles and a side, we can use the law of sines. So now we're going to talk about using the law of sines when we know two sides and an angle. Okay, so we're going to talk about that now. All right, we know two sides and the angle isn't in between the two sides. Okay, so we're going to talk about that next. All right, so now we're going to talk about the side-side angle case, or SSA, or if I like to say ASS. All right, so this is a triangle when you're given A, B, and then side A. Or sorry, side A, side B, and angle A. So one of the angles opposite the side I gave you. So just one of them. You can sketch a bunch of different triangles based on that. And we're going to figure out what type of a triangle can be formed. And we're going to use the fact that H equals B times sine A. So we're going to talk about H for a second. Okay. So there's two different cases when the angle I give you is obtuse and when the angle I give you is acute. There's two different ways of doing that. Okay, so first let's talk about when I give you side A, side B, and angle A is obtuse. If side A is less than B, it's never going to make it to this other side over here. So there's no triangle that you can make. So if I gave you angle A and side A and B, so in other words, what I'm saying is if I give you two sides and one of the angles opposite one of those sides, right? So if I give you like B and C and I give you angle C, or if I give you A and B and I give you angle B, you know, one of the angles have to match the side. This is when we're going to check. So first we're talking about that angle being obtuse. If side A or the angle opposite the obtuse angle is less than the other side, if the side opposite the obtuse angle is less than the other side I give you, no triangle can be made. If it's bigger, then one triangle can be made. And we only need to talk about that one triangle, and we go ahead and just use the law of sines to solve. If it was no triangle, then we wouldn't use the law of sines to solve. We would just move on with life. Okay. So then we're going to talk about H. And again, H is B times sine A. So if A is acute, we need to find H. We're going to do that first and then see how it rolls. If H is bigger than side A, no triangle. Doesn't make it its way there. If H equals A, then we have one triangle, and it's right. If H is less than A and it's less than B, then we can have two triangles that can be made. One where the side is here and one where the side could be there. We can move the side to hit in those places. Okay, so the side can be, they come from the same angle. I can pull the side here and get hit, but then I can open it back up and they can hit there. So two triangles can be made, and we'll have to talk about those two triangles. And we'll have an example like that. And then if A is greater than B, If we just right away know A is greater than B, only one triangle can be formed. All right, so we're going to do examples of this. We're going to do 3 examples. All right, and we'll talk about, how once we know if a triangle be formed, and if it can, how many triangles can be formed, how do we use the law of sines to find our missing sides? Again, this is for angle side case. 2 sides and then one matching angle to those sides. All right, example 1. So I'm going to give you A is 29 degrees, and then A equals B. No, A doesn't equal B. A equals 6. Can't remember. And B is 13. Okay, so here's your angle side scenario. I have 2 sides, A and B, and I'm talking about one of the angles opposite one of those sides, angle A. So first of all, is it obtuse or acute? This bad boy is acute because this angle is acute. All right, I'm going to find H because I'm going to use that to figure out if any triangles. So I'm going to do B times sine of A. Okay, so the angle I'm given in the other side. So whatever angle I'm giving, and then the other side, not the side opposite, but the other side. So let's see, 13 times sine of 29. Make sure I'm in degree mode. I get H is 6.3. All right, so H is 6.3. That's bigger than A, but less than B. Oh, it's bigger than A. So no triangle can be formed. I'm not even going to try the law sign. Okay, no triangle. I'm done. Problem's done. This would not make a triangle. All right, so again, find H. You only do that if your angle's acute. If your angle's obtuse, you just got to see, is A bigger than B or is A less than B? But for acute, you got to find this H and then do comparing with all that. All right, so example 2, we're going to do A is 110 degrees, A is 20, B is 8. We have an angle side scenario here. All right, this time 110 is obtuse, so I just need to compare A and B. So let's see, 20 is bigger than 8, so that's one triangle, and I can just use the law of sines. I'm ready to go. I can just use that law of sines like I have been doing it. So 20, okay. All right, let's find sine of, well, let's see, what do we need? We need C, we need angle C, we need side C, we need angle B. So let's find angle B first because we have the information. We can use that to find B. We know nothing about C yet. All right, so let's see. Side A, angle A, side B, whoops, which is 8, over sine of angle B, which I don't know. All right, so I'm going to cross multiply. 20 times sine B equals 8 times sine of 110. I'm going to divide by 20. All right, and that gives me sine of B equals, I think about, that's what I got when I put in the calculator. All right, so what I do to find angle B, if you remember, is I'm going to do inverse sine. So B is going to be inverse sine of 0.3758. So angle B is 22 degrees. I got about 22 degrees. Okay, so I know what angle B is. I know what angle A is. So now I can find angle C. So the measure of angle C equals 180 minus 22 minus 110. So that's going to be 48 degrees. And now I can find side C, right, using the law of sines. So sine, actually, let me write this over here. Over sine of 48 equals side A over sine of angle A And then I'm going to cross multiply. So sine of 110 times c equals 20 times sine of 48 divided by sine of 110. And I get c is 15.8. So now I have all information from it. So again, how many triangles can I make? Can I make a triangle? And once I do it, then I just use the law of sines. If I'm finding an angle, I would use that inverse sine function. So we're going to do another example. A equals, oops, no, C equals 13, B equals 16. I'm going to solve for the angle. Actually, I'm going to keep it to A and B. Let's not confuse ourselves too much. All right, so this guy is acute. Acute. All right, so since it's acute, I got to find H. So it's going to be 16, which is B, times sine of 40. And when I put that in the calculator, I get 10.3, which is less than A and B. So H is less than A, and it's less than B. So, two triangles. Okay. So let's try to talk about triangle 1. Let's just solve it, and then we'll talk about triangle 2. And we'll do triangle 2 in a second. All right, so triangle 1, we're just going to do like we did the other problem. 13 over, we're going to find angle B first. So 13 over sine of 40, so side A over angle A, side B over angle B. Cross multiply, 13 times sine of B equals 16 times sine of 40. Divide by 13.
Ain't supposed to get any snow till 7.
Sine of B equals 2.7911. So then all I have to do is inverse sine. So I'm going to do inverse sine of that decimal, and I get 52 degrees. All right, so B is 52 degrees. So that means, I'm going to erase this triangle too. C is going to equal 180 minus 52 minus 40, so it's 88 degrees. So side C over angle C equals side A over angle A. Cross multiply. And then divide by sine of 40. So I get C equals 20.2. Okay, so that's case 1. That's case 1. Pretty straightforward, did like I did before. But in this case, what if instead of side B being the 52 degrees, that side B is actually the 88 degrees. Oh, no, I didn't mean that. Instead of, sorry. That is not the other case because we just have the same sides. So instead of being 52 degrees, the other scenario would be its supplement. Okay, so minus 52 is 128. All right, so if it was 128 degrees, so instead of being the acute angle that matched up, it'd be the obtuse angle that would match up to that. Okay, so again, this is the supplement to the original angle that we talked about over on the other side. Okay, so if that was the case, then angle C would be 180 minus 128 minus 40 would only be 12 degrees. So the side C that will go with that, I would use 12 for the angle C. And I would cross multiply. So sine of 40 times C equals 13 times sine of 12 divided by sine of 40. And C equals 4.2 in that case. So triangle 1, if your angle A is acute, you get H is less than A and less than B, then you can have a case of two triangles where B would be, first we would talk about B being acute. Okay, we would talk about B being acute. And we would find angle B. We would just use the law of sines to find angle B, and you see, oh, it can be 52 degrees, but it also could be opened up to the obtuse. So if you look at the picture above, it can be obtuse of that, which is, in our case, the supplement of that angle, so the supplement of 52. And in that case, we'd have to talk about B being 180 minus that, so 128 degrees. So that would make C only 12 degrees, so then I would have to find out what C is in that case as well. It would, you know, it'd be a shorter side in that case. Okay, so two triangles. In that case, you find B, then do it again, but with the supplement of B, and then find your C. So again, so this is for the angle side case. All right, the law of sines sort of is used, well, it just fits in here. We can find the area of any triangle by 1/2 the product of the lengths of two sides times the sine of their included angle. So what I mean is the side angle side scenario. So if I know two sides and then the angle in between them, then I can find the area. So I either know sides B and C and angle A, or sides A and B and angle C. So notice I have to have the two sides and the angle in between, which is neither one of the sides because it can't be that angle opposite them. Okay, so notice there's an A, B, and C in each of the formulas. Either the two sides B and C and the angle A, or the two sides A and B and the angle C, and so on. So let's do an example. All right, so here's an example. Let's say I know side A is 1.4 meters, side B is 2.3 meters, and the measure of angle C is 78.1 degrees. All right, so I'm going to use, I know A and B, and the side in between them, which is C. It's that angle, make sure all the letters are there, if you will, just like two of them are the sine and one of them is the angle, and I just substitute in 1/2 times 1.4 times 2.3 times the sine of 78.1. Type that on the calculator, make sure I'm in degree mode, and I get 1.6 meters, and then area is squared. All right, so that form is actually pretty straightforward to use. You just got to know two sides and the angle between it, and you can find the area of any triangle. Again, I always ask if you have any questions.